Linking datasets is often pretty straightforward. We just find a common unique identifier and link them together. This is called deterministic data linkage, and I've done a few videos on how to do this. But sometimes we need to link datasets that don't have a unique identifier. And although things like first and last name can be pretty unique, the smallest typo or change can throw things off. In these cases, we can use probabilistic data linking. And so in the example below, we want to link John Doe in both datasets, but John is spelled differently, so we can't link the first and last names. But since both names are nearly identical and the last name and birth dates are exactly the same, we're pretty confident that these rows should belong together. That's the power of probabilistic data linking. And so with that, let's get right into how we do this. All right, so what we have here are two data sets or employee data sets. They have unique identifiers, but they don't match up. So you can see student ID here, employee ID there. And now these names are supposed to line up. You have John Doe here, John spelled differently in the left side than the right side, but we're going to use probabilistic matching to get those. You can see a lot of the information lines up here, but not exact. So that's what we're going to try to do here. We're going to try to line those up based on probability. All right, so first thing we need to do here, let's open a new Python file. Go ahead and go to new file here. Before we get too far though, let's go ahead and save this in the folder that we want to work in. And then we're going to have to use pip to install some modules, just two. Shouldn't be too bad. All right, so if you're Windows, what you want to do is just search for CMD for the command prompt. And it's pretty simple. Just do a pip install pandas for data management and then also for record linkage. And that's what we're going to use the probabilistic linking for. So I already have it, just showing you how it's done. All right, let's go back to Python. Okay, the first thing we want to do is import our modules. So let's start with pandas, import pandas as PD, and then we want the record linkage module as well. So we're going to import that. Pretty simple stuff. Now the next thing we want to do is import our two employee data sets. So these are Excel files. I'll just do pd.readExcel, import those, have two different data frames here. Bam, we're done with that. Easy. Now right here, we want to make sure that the birth date column of both data sets is the right format, so a real date. So this is going to loop through each data frame, df1 and df2, and make sure they have a column called birth date. And if it does, it's going to make sure it's in a proper date type. Now the coerce part right here just means if something doesn't look like a date, turn it into a blank cell instead of crashing the script. All right, this next section is my favorite. It's the index all versus all section. And basically what it does is it pairs every record between the two data sets to find the best match. So basically we're saying take every row in data set 1, compare it to every row in data set 2, and that's called an all versus all comparison. And what it does is it's going to find the best match. We're going to tell the linker how to compare rows from a few different fields. So we're going to compare first name, last name, city, using a method called Jaro-Winkler. Some people pronounce this as Jaro-Winkler or Jaro-Winkler, doesn't matter. For the purposes of this video though, I'm going to call it Jaro-Winkler just for simplicity here. What it's going to do is produce a score for each comparison between 0 and 1. One's going to be a perfect or near perfect match. 0 is going to be completely different. And then for the birth date, we're going to do this differently. We don't want to compare strings. We're just going to do all or nothing. So either the birth date is correct or it's not. Jaro-Winkler is great though for typos or small spelling differences, especially at the beginning of words where people notice the errors the most. So for features here, we're taking the similarity scores for each field and rolling them up into one overall map score so we can rank which pairs look like the best matches. Now for this section, right now the pair of row numbers from dataset 1 and dataset 2 are hidden in the index. So resetting the index just turns them into regular columns, which then makes it easier to merge back with the full datasets. Now, when we export this, we're going to have fields from both data sets. So I'm putting df1 underscore the field name. So first name, for example, df1 underscore first name, df2 underscore first name. So we know the difference between fields from each data set and where it came from. So what we're doing here with merge is we're using those pairs that we created earlier. It gave us some row IDs that allow us to merge the two data sets by creating level 0 and level 1. And it's going to merge them, bring them together, and then subsequently, we're going to get rid of those row index identifiers in the next section. We're at the merge.drop section. We're going to get rid of level 0 and level 1. They've already served their purpose. And then we're going to go ahead and save our outputs, merge to CSV. We're going to make index false unless you want a index ID for each row. Go ahead and switch that to true if you do. And then after that, we're going to create a separate export, and it's going to have our high confidence matches only. So this is only going to include matches where the score is 2.5 or higher. Now you don't need this, but I always like to have a statement that just says done so you know the script is done. So let's go ahead and run this and let's see how it does. Let's go run module. And if you have a lot of rows, this might take a long time, but I don't have a ton, so it shouldn't be too bad. But that's what happens when you do an all versus all approach. It does take a lot longer because it's using a lot more bandwidth. Let's go give it a look. So by default, this is going to be in the same folder as your Python script. So let's go ahead and open our first one here. And this is going to have the matches. All right, so let's take a look here. So I think for the most part, everybody here should match up pretty well. It's questionable about row number 3 with Jane Smith and Janet Smith. The birth date is just one day off. They're both from Los Angeles. It's very similar, but it might not be the same person. So maybe for something like this, you may want to change the threshold match score to 3 or higher. As you can see, the 2.85 here is questionable. Not 100% sure about that. You got to make a call sometimes. If you can get more contextual information, that really does help. No. Let's take a look at the all versus all export. Now this is cool because it tells you the best possible matches in every situation. So this could add up pretty quickly, but this is very helpful. Now you can see that the Jane Smith and Janet Smith matched up. That was the best possible match, but it still might not have been an actual true match, but you'll have to decide that. Anyway, I hope you found this video helpful. If you did, please make sure to like, subscribe, and comment. I really appreciate it. In the meantime, thanks so much for watching and take care.